In this problem, we're told a merry-go-round accelerates from rest to 0.68 radians per second in 24 seconds. Assuming the merry-go-round is a uniform disk of radius 7 meters and mass 31,000 kilograms, calculate the net torque required to accelerate it. So let's go ahead and solve this problem. So let's go ahead and write down the given first. So what are we given? So we told that the merry-go-round is going to accelerate from rest to 0.68 radians per second. So what they're telling us is the initial angular velocity and the final angular velocity. So the initial angular velocity is going to be 0 because it starts from rest, so 0 radians per second. And then it's going to go to 0.68 radians per second. And so the time interval this is going to take is 24 seconds. So we can just write delta t. The change in time during this is 24 seconds. So that's going to be delta t. We know it's going to be a uniform disk of radius. So they tell us the radius, which is 7 meters. So that's that. And then its mass is going to be 31,000 kilograms. So what we're trying to do is find the net torque required to accelerate it. So we're trying to find torque. And so in order to solve for torque, you need to know this formula. Torque equals inertia multiplied by angular acceleration, or alpha. So this is the formula you use to solve. And so the reason we use this one is because notice how we're given radius and mass. So what we can do is with those, we can calculate the inertia. And then in order to calculate angular acceleration, we have a time interval. And then we have the initial and final angular velocity. So we can calculate angular acceleration. So let's go ahead and solve. So let's start by finding angular acceleration. So alpha is equal to, you need to know it's the change in angular velocity over the change in time, right? So we got to find this. So think about how this works. So we know the change in time is 24 seconds, right? So 24 seconds, we know that. And then the change in the angular velocity is just going to be the final angular velocity minus the initial, right? The final is 0.68 radians per second and the initial is 0. So really it's just 0.68 over 24. And make sure when you do this, it's in radians per second, and then this is in seconds. Because notice what angular acceleration is measured in. It's radians per second squared. So just make sure your units line up. But yeah, so 0.68 over 24. I'm just going to leave it in fractional form, but you could just multiply it out or divide this and then plug it in. But I'm just going to leave it like this for when we solve. So 0.68 divided by 24 radians per second squared. So this is your angular acceleration. Now let's move on to inertia. So what is inertia equal to? So inertia, there's different equations depending on the type of object, right? Depending on your type of object. In this case, we have a disk, a uniform disk, and we're trying to calculate the torque of it, right? So in order to calculate the inertia of a uniform disk like this, there's a formula you should know, which is 1/2 mr squared, right? So it depends on the type of object. In this case, we use this equation. In your textbook, they should have different equations depending on the type of object. But in this case, it's just going to be this equation right here. So 1/2 mr squared. So yeah, this is the equation for inertia. So let's just plug in our values because we have both of these, right? We have the mass, which is 31,000 kilograms. Make sure this is in kilograms. This is in meters, by the way. They are in our case, but if they're not, make sure they are. Times 7 squared. And 7 squared is just 49. So I'm just going to make it 49. So essentially, this right here is your inertia, right? So this is your inertia. Keep in mind, this is kilograms. This is meters. So you can write that in if you want. But now we've got the inertia and we've got the angular acceleration. So we can just solve. So torque equals 1/2. I'm just going to write it as 0.5 actually. So 0.5 multiplied by 31,000 multiplied by 49. Right? So this whole thing is your inertia, and then multiplied by the angular acceleration, or alpha. So 0.68 over 24. So if you go ahead and do this, let's just plug it in actually. 0.5 times 31,000 times 49 multiplied by 0.68 divided by 24. So if you go ahead and do this, you're going to get that it equals 21519.16 and so on. So I'm just going to round to 7. So keep in mind the units for this. This is Newton meters. So Newton meters. What I'm going to go ahead and do is just round this to 22,000 Newton meters. and then I want to put it in scientific notation. So 1, 2, 3, 4. So 2.2 times 10 to the 4 Newton meters. Right, so this is it in scientific notation. Just make sure you choose the one your teacher wants you to do if they want the more exact answer versus rounded. But yeah, so this right here is going to be your answer, 2.2 times 10 to the 4 Newton meters. So yeah, hopefully you found this video useful.